Hello, Michael here from Small Robot Studio with another Renderman tutorial. Today we're going to be having a look at how to assign PBR textures to your objects. Now, PBR textures are made up of physically based rendering layers to make your objects look more realistic with specific maps designed for specularity, diffuse, also known as albedo, and normal maps and displacement. So I'm going to go over a couple of common situations that you might come into when you're trying to set up your shaders. And hey, make sure you're subscribed with notifications on, otherwise you may be missing out on the many tutorials that we're releasing for free each week here on YouTube. So I've just got a very simple ball here. And what we're going to do is we're going to assign a PxrSurface shader to it with it selected, and then we're going to go into the Hypershade editor. We'll select our shader and map it out here in the Hypershade, and then we're going to start bringing in our textures. So to do that, we need a PXR texture node, which type that in and you'll search and find it. Then we're going to go to the Open button here, and we will look for our textures. And it's always best to be keeping your textures and things inside the project folder, which you should already have created for your scene. Now I'm going to import a few different ones here. We'll start with the diffuse, which is for this metal plate texture. I've got it off texturehaven.com, which is a great website. You should consider supporting them on Patreon. So the first thing, our diffuse, I'm just going to select that node and open it up with 3, and then we're going to run the result RGB into the diffuse color. Then I can shrink this back down by selecting and hitting 2. Then we're going to create another PXR texture node, and we're going to open the specular face color, which will here be known as specular or just spec. We'll run the specular into the specular face color, and then again we can actually just Control D on that, and that will create a new PXR texture node, but we'll have to change its target file to be now the roughness. And the roughness is referring to the specular roughness, not the diffuse roughness, which you may have been confused about. So we'll run that specular roughness into our specular roughness, but you'll notice that we can't because roughness is expecting a value between 0 and 1. And if you look at the preview of our map here, you'll see it's black and white. So black means the value of 0, white means the value of 1. Value of 1 means rough in this case. So we'll run that into the specular roughness using our result RGBR output. Because this is only a black and white file, using one of the 3 RGB outputs is fine because they're all the same output, even if we use the G or the B. Next, we'll grab a bump, which we can use with the PXR bump. And this map that I've got here actually comes with 2 different types of bump. We have a normal map and a bump map. I'll show you the bump map first, and then we'll compare it to the normal map. And again, you'll notice that the bump map is also a black and white file. The values of 1 mean a higher bump, and the values of 0 mean no bump. So we're just going to run the result in into the bump normal. And that is pretty much everything you need to get started there. So we'll hit IPR, and you'll get something that looks like this. That's not very good. We need to assign a subdivision scheme to it. So go into its attributes and go to Catmull-Clark, and then we are going to also prevent polygon cracking, and this will smooth it out, and when we assign displacements to it in a second, it'll also prevent it from cracking. So you'll see I've got all the materials assigned here, but we have some erroneous things happening. If you look at the treads, they are actually going inward, and that's because our bump is inverted. So depending on what software was used to create these maps, sometimes the values are inverted on particular axes. We can fix that quite easily though. Now, a number of things may be causing this. It could be a matter of inverting the T. It could be a matter of reversing the normal. But for this particular one, it's the Atlas style. So we need to change the Atlas style to a UV tile base 0, and you'll see now that the bumps are protruding outward. The thing with bump maps is they're not actual physical displacement of the surface, so they look decent from a distance to apply a little bit of extra realism to background textures, but they don't actually affect the physical light bounces as realistically as you would expect from a normal map or a displacement map. So why don't we change that bump map into the normal map? This is the same thing. We want to run the normal into the bump normal, and then we're going to open the normal map, and you'll see the normal map comes with a bunch of colors on it. Those colors are indicative of the vector in which the light is going to bounce off the surface. So again, our map appears to be inverted. Those treads are actually meant to be popping outward. So we could invert the bump and that will fix that up. So if we compare this normal map to our bump map, you'll see that while this does appear to be bumped here, when you're facing straight on, it doesn't actually give a very realistic impression of a bump. Whereas because the normal is able to bounce the light away on a specific vector, depending on where it hits the surface, you're getting a much more realistic result. Though again, this is not physical displacement of the surface. You'll see on the silhouette, there's actually no bump. It's still a perfect sphere. To get physical displacement, we actually need to add in a displacement. So I'm just going to hit tab and type in displace, and we'll get a PXR displace. And we want to run this out color from the displace into our out displacement shader, which is already connected to our PxrSurface. So we can get rid of that shading group, and we just need this shading group. And then we need to grab the map. So we're going to go PXR texture, and we'll grab our displacement map. Now the interesting thing about this map that I noticed, and this is worth noting just in case you run into a similar thing, is it's completely grayscale and is actually not a displacement map. You'll see it's displaced everything evenly, however it's not actually displaced anything differently from another. We still have an even surface around the edge. All it has done is made it bigger, and that's because it's displacing everything by a value of 0.5, and we're using scalar rather than vector because I would have assumed that this map should have a vector displacement, but it doesn't. So what you need to look out for here is if for some reason your map doesn't work, but you did actually get a bump input, you could use that instead with your scalar input. Now, if you do have a displacement map and it appears colorful, that means you have a vector displacement and you can plug the RGB into the vector displacement. But because we're only using values between 0 and 1, to use the scalar, which is just displacing the surface upward and downward, so on one axis, we're just going to use the single output from the RGBR into the scalar. And then when we render this now, you'll see that we get this incredibly displaced surface. So now it is just a matter of adjusting our gain. And because we're using that same bump map from before, you'll also notice that the surface is bumped inverted. So another way that we can fix this, because on this particular one, changing the Atlas style won't work, we can just use a PXR invert. And what that will do is if we just run the RGB into that, and then use this RGBR out into the displacement scalar, and run the IPR, it'll invert all those values. So values that are 0 will be 1, values that are 1 will be 0, and then that way we get the bumps on the treads that you'd expect. This way it's just a matter of deciding how much bump you need, or displacement you need. And there we go. So just changing the gain down to 0.025 has given me a fairly decent result. It is quite bumpy. We can do things like thresholds and whatnot to... Okay, there is one final map that I've yet to mention, and that is ambient occlusion, or also known as AO. Ambient occlusion isn't really used for PBR in offline renderers like Renderman. You can still use it if you wish. This would be an artistic direction choice and not a necessity, because all ambient occlusion really is secondary ray bounces being simulated in a texture rather than in geometry space. So what we can do though, if you do want to use it, is the same thing. We'll grab a PXR texture and we'll open the ambient occlusion for this one. And to use it with your shader, what you want to do is multiply it with your diffuse color. So we can just use a PXR blend for this. And we'll run the RGB out from the diffuse into the top RGB, and then the RGB out from the albedo from the ambient occlusion into the bottom RGB. Then that out can just go into the diffuse color. We also need to make sure that we have the blend set to multiply. So for reference, this is without the ambient occlusion. If we render the ambient occlusion, this is with the ambient occlusion. So if you switch between the two, not a huge difference. You'll see a value shift. That's up because ambient occlusion has a lot of dark areas, which means to simulate occluded shadow in sort of tight spaces. So if you're trying to maybe get a little bit more detail out of your texture map where you might have some cracks and things like that, and you want to show that up a bit more, you may want to use your ambient occlusion. You could also blend it out using the alpha. Now, one other type of map that you may run into when you're trying to assign PBR materials is a metalness map. Now, Renderman PxrSurface is not really set up to easily handle these, but you can still use them. For this example, I've just generated these maps using 3D Coat, and this is obviously a metal style texture. So I've exported this as both a specular PBR and as a metalness PBR, and I'll show you how I set them up. So on the left, I'm going to use specular face color rather than metalness, and on the right, I'm going to use the metalness. So you'll see I've already set up the maps for the left-hand one. I've added an HDRI, so it's a little bit easier to see these because they're quite dark, obviously, with a metal material. So what I'll do here is I'll open up the three maps that I'm using, which are the diffuse, the roughness, and the specular face color in Photoshop. Okay, so this first one here is the specular face color. And if we look at our metalness maps, we have got the same maps. We've got an albedo, which is the same as your diffuse. You've got metalness and you've got roughness. So we'll open the metalness. You'll see the metalness just consists of a black and white layout. Now all this is a mask. So we could actually use this as a mask to mask off the areas for the object that are metal. Now this entire object is metal in this case, but you might have some areas of your mesh that are only partly metal or have some amount of metal to them. So you will have a similar looking mask, and I'll show you how to hook that up in a moment, but we'll just compare the rest of the maps first. The next we have the metalness albedo, and if you switch over to the specular face color, you'll notice that they are the exact same map. So that gives us an indication that we'd actually be able to run this into our specular face color and have it work. We have the metalness roughness, and if we look at the roughness map that we have from the specular workflow, you'll see it's also the same. The only map that we don't have is the diffuse map. So if we look at our diffuse map, what you'll notice is that it is completely black. So essentially any area that is black should appear metal. Now in this model, again, the entire thing is made of metal. So understanding all that, we'll assign a new PxrSurface to our right-hand ball, and we'll bring in those maps. So we know that our albedo map is the same as our specular face color map. So instead of using that as our diffuse input, we're going to use that as our specular face color input. We know that our roughness is the same on both, so we'll create another PXR texture for that and just plug that into the roughness the exact same way. And finally, our diffuse color is the last thing left, and we know that looking at our diffuse color, it is just black. So in this case, we can just set the whole thing to be black. Now finally, we need to get the metalness, and we know this is essentially going to work as an alpha. So what we can do to define the areas that are getting metalness is we can actually multiply it by our specular face color. So if we use a PXR blend, we'll run the top RGB into that, we'll run the bottom RGB into that, and then we'll run the result RGB into the specular face color. And then the last thing we need to do is set our operation to multiply. Now the reason this will work is because our map will look at any areas that aren't metal, the black areas, set them to 0. So when you multiply a number by 0, obviously it becomes 0. The metalness areas are white, so when they're multiplied by 1, the map will stay the same. So if it has a value of 0.5 times 1, it's still going to be a value of 0.5. So you'll see now that when they're rendered up, they render up the exact same way. So now that you understand how the metalness map works, let's have a look at how it would work if we actually had a mixture of metal and, say, a plastic style or diffused material. So I've just added a orange diffused shader to the top of this ball in 3D code, and we'll assign those maps now. But first we'll just have a quick look. So the first thing you'll notice is that the albedo map that we created for the metalness, which should be the same as our albedo here, has the orange on it. However, this area we would actually want it to be black because it's going to be the area that's actually all metal. And you'll notice that the metalness map has got metalness assigned to the area that we want it to be metal, which is the areas that are not orange. So what that means is that this part of the setup is going to be the exact same. We're just going to get the albedo and multiply it by the metalness using a PXR blend and send it into the specular face color. Now I'll set this up separately so it's a little bit clearer. So I'm just going to grab two PXR textures again, and I'm going to open up the metalness and the albedo, and then we're going to run this into a PXR blend just using the RGB top and bottom, and then run that result RGB into our diffuse color. Make sure you set your blend to multiply, and if we render here, we'll see the problem. So our metalness map is actually doing the opposite of what we want it to do. So to fix this, we've got our metalness here. What we can do is just set up an invert, which is a PXR invert node, and we'll run that into the input RGB and then the result RGB into the position that it was previously. So now you'll see that we get the expected result. Now because you have this mask, so if you wanted to add any differences to this part of the map, for instance another amount, you wanted it to be specular rather than diffused. Now I only exported it as diffused. However, I could still make it specular by running this invert RGB into rough specular phase color, which will give us an extra input for specular. I could reduce the roughness there and run the IPR. And to show this a little bit better, I've just increased the roughness. And what we get here is a rough specular painted top, just by using that map there. So understanding how these metalness maps work will allow you to add all these extra masks and control your materials inside of Maya or whichever DCC you're using for Renderman a lot easier. So this hopefully should explain it for any of you out there looking to use metalness maps as well as all your other standard maps as well. That's it for this tutorial. If you found it useful, make sure you leave a like so other people can find it. And if you haven't already, make sure you subscribe as we're bringing out CG and illustration tutorials every week, just like this one. Become a patron and access tutorial assets, bonus content, a private Discord and more by clicking the link below.